Okay, so yesterday we were talking about burning alcohol, and we came up with the question, as we burnt the alcohol, we observed that the mass went down, and we came up with the question of where did it go, right? We had two main theories. One, it was either burnt up in the fire, or two, that it went somewhere else, maybe turned into a gas or something like that. Okay? In today's assignment, the vinegar and baking soda assignment, it starts off by asking the question, what does the law of conservation of matter state? Okay? Anyone heard of that before yesterday? You guys remember? Go ahead. Perfect. So it's that matter cannot be created nor destroyed. And then we talked about that it can only be changed. So just changed. Okay? So for our activity yesterday, what that means is that with our alcohol, that mass could not have been burnt up in the fire, right? It has to still exist, and we discussed how it's possible that it became a gas, which is why we no longer read its mass on the triple beam balance. So tomorrow, you're going to be given a challenge. Okay? Your challenge will be to mix vinegar and baking soda. Okay? But we're going to do it a little bit differently. In this vinegar, I've added a couple of drops of soap, a detergent to it, because as you mix vinegar and baking soda, it creates bubbles. And I want to be able to collect, or it makes gas, and I want to collect that gas. Okay? So if I mix these, okay, like this, it's going to create those bubbles, and it'll overflow. Can you guys see that? Okay? So it's overflowing. I'll lift it up in just a second so you can see a little better. And so your challenge tomorrow will be to find a good proportion, the correct proportion of vinegar to baking soda, so that it will foam up to the very top of the flask, but not overflow. Does that make sense? That'll be your challenge that you'll have. And you'll have a couple of tries to do that. This is our control, 10 milliliters of vinegar with half a teaspoon of baking soda. Okay? So on the slides, it asks you to write down your observations, draw this reaction, and then answer the question, is it a chemical reaction? Then on slide 3, it shows you the formula for this reaction. It wants you to label the reactants and the products. And then on slide 4, it wants you to show how many of each atom is in the reactants and in the products. Okay? We'll go until the last 5 minutes or so of class, and then we'll get back together and we'll discuss those, especially slide 4 if anyone's confused there, and be able to help you with that. Okay? Any questions? Good. All right, so this is picking up where we left off on slide 3. So on this slide, you have this equation written. It also has the ball model showing you an idea of what these different molecules would look like. And you're asked to record the reactants and the products. Now, if you remember, the reactants are kind of your building material, right? So we've said before, reactants are building materials. Okay. So in this reaction, our reactants, the things that we're building with, would be these molecules here. Okay. The vinegar and baking soda. The products is what is made or produced, which is where it gets the name for product. It's what's produced. So product is what's produced. Okay, so that would be these molecules there. Okay, so you've now identified those. In slide 4 of the assignment, it has a table. In that table, it's asking for the reactants and the products. That line's pretty bad. Let me redraw that line. There we go. That looks a bit better. Try and do this one while we're at it. All right. And within the reactants and products, it wants you to list how much carbon, hydrogen, oxygen, and sodium we can find. So to do this, we have to take it one molecule at a time. So if we focus over here on our reactants, let's start here with vinegar. Looking at vinegar, how much carbon is there? Well, there's two carbon atoms in the vinegar molecule. But that's not all there is within the reactants. There's also our baking soda, and within baking soda we have one carbon atom for a total of 3 carbon atoms in our reactants. For the hydrogen, we look once again at these molecules. In baking soda we have 4, in vinegar we have 4, and in baking soda there's 1 for a total of 5. And then for oxygen we have 2 and 3 for a total of 5. And for sodium, we only have the 1 in the baking soda and none in the vinegar, so that's 1. Then moving over to our products. In our products, looking at carbon, this molecule here has 2, water has 0, and then carbon dioxide has 1 for a total of 2 plus 0 plus 1 is 3. Then, when we look at our hydrogen, this molecule has 3, water has 2, carbon dioxide doesn't have any, so 3 plus 2 plus 0 is 5. For our next molecule, or for our next atom, oxygen, we have 2 in this molecule, 1 in water, and 2 in carbon dioxide. 2 plus 1 plus 2 gives us 5. And then lastly, for sodium, we have 1 in this molecule, none here, and none here, for a final total of 1. So we can see that the atoms we have in the reactants are the same as the atoms we have in the products. And that we didn't lose, we didn't gain anything. So when people say something like mass is conserved during a chemical reaction, what they're saying is that whatever you started with, whatever these atoms are that you started with in the reactants, those are the same atoms that you end with. None of them are lost, none of them are gained. That mass or matter is conserved.
Guys, so I thought I'd add in a little 2020 ending to this assignment. With this assignment, you could do this from home, this vinegar and baking soda, just by mixing some vinegar with some dish soap and then combining it in different quantities to make enough bubbles so that it doesn't overfill some type of container. So what you would need to do this from home is find some sort of cup or some other container, probably fairly small so you don't use too much vinegar or baking soda, and then maintain a control. You wouldn't be able to use the control I had in school, and then alter that control to see if you can get those bubbles to get as high to the rim of that cup without overflowing over the top of that cup. Okay, you should be able to do it from home, like I said, if you follow that kind of guidelines and you tweak it there a little bit.